So this question was asked in IIT JEE Advanced Entrance Exam 2022. So basically in the physics section, right? So the question is two capacitors with capacitance values C1 is equal to 2000 plus or minus 10 picofarad and C2 is equal to 3000 plus or minus 15 picofarad are connected in series. The voltage applied across this combination is V is equal to 5 plus or minus 0.02 volt. The percentage error in the calculation of the energy stored in this combination of capacitor is dash, right? So basically there are two capacitors, right? There are two capacitors and capacitor value is capacitor 1 value is 2000 and the error range is 10 picofarad. Capacitor 2 value is 3000 picofarad and the error value is 15 picofarads. So these two capacitors, that is C1 and C2, are connected in series, right? So capacitors you can have in either parallel combination or series combination. So in this connections they are put in the series combination, and across these capacitors, that means the capacitor put in series, and across this combination the voltage applied is 5 and error range in the voltage is 0.02 volt. So if this is the condition, we have to calculate the error in the, that is a percentage error in the stored energies. So how much error that is expected to have in the energy stored. Basically capacitor will store energy, and in that energy stored, how much error can be expected, right? So that is what we have to calculate. So to calculate the error in the energy of the capacitors, stored energy error in the energy storage of the capacitor can be calculated in 3 steps. First, we will calculate the capacitance, equivalent capacitance of the capacitors. That is, we have two capacitors and they are connected in series. For that, we have to calculate the equivalent capacitance. That means as a result of series connection of C1 and C2, what is the resultant capacitance value that we will get, that we need to be calculated. In the second step, so what is the error in the capacitance we have to calculate, that is for the equivalent capacitance, what is the error in the capacitance. Third step is error in the energy storage stored in capacitors we have to calculate. So we will just see how each of this is done. First step, so equivalent capacitor for series connection. For two capacitors in series, the equivalent capacitance C is 1 by C is equal to 1 by C1 plus 1 by C2. That means we have two capacitors, we have to calculate equivalent capacitance. The relation is 1 by equivalent capacitance value is equal to 1 by capacitance value of first capacitor plus 1 by capacitance value of the second capacitors. If you do that, we can calculate the equivalent capacitance, that is 1 by equivalent capacitance. From there we can calculate the equivalent capacitance. Suppose if you have 3 capacitors, then we have to add one more capacitor value, that is 1 by C1 plus 1 by C2 plus 1 by C3. This can be extended up to n capacitor values. Suppose if I have n capacitors, we have to have the same combination 1 by C1 plus 1 by C2 plus etc plus 1 by Cn, right? Like that we have to calculate the equivalent capacitance for the series combination. So then given value is C1 is equal to 2000 plus or minus 10 picofarad, and C2 is 3000 plus or minus 15 picofarads, right? So, and V is equal to 5 voltage, right? So 5 plus or minus 0.02 volt. So now 1 by C is equal to 1 by 2000 plus 1 by 3000 picofarad, and if you simplify that, what you will get is 3 plus 2 divided by 6000, and 1 by C is equal to 5 divided by 6000 we will get, that is 1 by 1200. So therefore C is equal to 1200 picofarad. That means the equivalent capacitor of these C1 and C2 is 1200 picofarad. That means the equivalent value of this capacitor, if you put in series, is this much. So in the step 1, right? So in the step basically 2, error in capacitance we need to calculate. So that is delta C by C is equal to delta C1 divided by C1 square plus delta C2 by C2 square into C, right? So therefore delta C1 is equal to 10 picofarad, delta C2 is equal to 15 picofarad. So therefore delta C by C is equal to 10 into 10 power minus 12 divided by 2000 into 10 power minus so that is C1 is equal to 2000 into 10 power minus 12 the whole square. Likewise for the error in the capacitor 2 is 15 picofarad, that is 15 into 10 power minus 12 divided by C2 square is equal to 3000 into 10 power minus 12 the whole square into C1 we have calculated, that value is 1200 picofarad the whole square. If you simplify this, what you will get? So you just take 10 power minus 12 picofarad, that is our picofarad out. So you can cancel this picofarad and this picofarad. So what you will get is 10 divided by 2000 square plus 15 divided by 3000 square into 1 by into 1200 square into 10 power minus 12. That means picofarad we have here. So that means 10 divided by 4 into 10 power 6, 15 divided by 9 into 10 power 6 into this is again 1.44 into 10 power plus 6, right? So what will happen here, this plus 6, so what you can do here is you can just take this 1 by 4 is equal to 2.5 into 10 power minus 6, this number will goes up. Likewise 1.5 divided by 9 is equal to 15 divided by 9 is equal to 1.6 into 10 power minus 6 into, so this value, right? So 14 114 1.44 into 10 power 6 will be there. So this if you just write it in terms of power 6, then 4.17 into 10 power minus 6, 4.14 into 10 power plus 6, this will get cancelled, and therefore if you multiply these two terms, 6 picofarad will be there. This picofarad will be as it is. Delta C by C is equal to 6 picofarad. We want the error, percentage error in the capacitance, therefore 6 divided by 1200, that is delta C divided by C C into 100, right? So percentage, therefore it will give 0.5 percentage. So step 3, error in the energy storage of capacitor, that is energy storage in the capacitor U is equal to of CV square. So therefore if you differentiate this equation, log and you just take the logarithm of this and differentiate that, log U plus log C plus log V square. So if you differentiate that, du by U plus d, so this is dV by du and then dC by d plus 2 dV by V, right? So that's what you will get after differentiation. So you can write as a delta, the V, actually this is U, right? So delta U by U is equal to delta C by C plus 2 delta V by V. So if you delta V by V is equal to 0.02 divided by 5. So that is again 0.4 percentage. If you calculate into percentage, delta U by U is equal to 0.5, right? So 0.5. So plus that is, we calculated delta U by V is equal to 0.5 percentage plus 0.4 the whole square, sorry, into 2. That means in this equation we have to substitute this value. So therefore what happens, 0.5 percentage plus 0.8 percentage will becomes delta C by C is equal to 1.3 percentage. That means the error in the energy storage of the capacitor is 1.3 percentage.